Well, hello, everybody. Welcome back. We are in this journey along the way of course, learning about motion and seeing where that takes us. We needed to take a little detour to get some understanding of units so that we can work with units in some of the upcoming problems that we're trying to solve and understanding things. But I'd like to take a road back to visualizing motion at the moment. When we started this journey, we did our stop motion animation, and stop motion animation was a really great way to start to get into think about motion as being kind of this set of frozen images. And then those images, if they were played fast enough, would be kind of actual motion. And in many ways, that's the way we think about visualizing motion too. And so we're going to play around with two different aspects of this. The first one just for a moment, and then the other one a little bit more in depth, of gaining a real understanding of kind of how motion works by looking at some of the graphs behind motion as a whole. So here's our starting point. Let's start looking specifically at some motion diagrams. Motion diagrams are very much like onion skins, if you remember doing that with the stop motion animation, if that's something you played around with. So let's look at a motion diagram. We'll start with this really basic one. Imagine right now that you're looking at a picture right here that is not a single picture, but actually a whole bunch of onion skins laid on top of each other, right? So that you've got lots of pictures all at once, and each of those pictures is separated by a certain amount of time. Let's say that's separated by 1 second apiece. So somebody took a picture of this person, and then a second later, they took another picture of this person. And then a second later, they took another picture of this person. And then they laid all of those images right on top of each other so that you could see all of them at once. And then they ask you this question. What can you describe the motion of that person? And the answer is pretty clear, is that person's not doing anything. They're just stopped there. However, if you were to take a motion diagram that looks like this, and let's say we took 5 photographs, a second apiece from each other, and lay them on top of each other, this is clear that because this person is no longer in the same place, they have changed their position over time, then we have an idea what their motion is. In fact, we could probably describe that motion. We could say that on the left-hand side, through the right-hand side, they're moving at a constant speed. They're not speeding up. They're not slowing down. They're just moving from left to right based on kind of the position of the feet and the arms at a constant speed. They're not speeding up or slowing down. On the flip side, this motion is showing somebody that is speeding up. Think about each of these photographs or each of these pictures taken 1 second apart from each other. And I can tell they're speeding up because right over here, they're much closer together. And so if this picture is 1 second from this picture, is 1 second from this picture, they are traveling a greater distance between each of these shots. In order to travel that greater distance, they must be moving quicker. Same thing here, only this time around, they were moving quickly, and then they start to decrease that motion or slow down. So this is one way to think about motion. But we can take this same snapshot idea and translate it a little differently in order to understand this over time. So I'd like to reference it through a streetcar. I taught in San Francisco for many years, and my commute, I used to live in the Sunset area, if you know anything about San Francisco, and I taught in the Mission, which put me kind of walking right through the Castro every single day, so I would see this train car every day. And so I'd like to think about train cars recognizing that they run on tracks, which means that they just move kind of forward and backwards. Yeah, the tracks can curve, but let's think about a straight track for the moment, kind of like this track right here. So if this was the streetcar, the motion of that car can either be forwards, right, or it could be backwards. They can't veer off the track because there's nowhere else it could go. It has to stay on the track. But we could think about this forwards and backward motion, and we could drag that through time. We could say, well, what if we just kind of moved this through time, left and right? Now, the motion of the car is still just going to be straight up and straight down. But if we were to slide this kind of in time, not space, but in time, we would get something that looks more like this. Or if I was to kind of take different pictures at different times, kind of like those motion diagrams, then I would say, hey, the train car is at this point here, at this point at this here, and so on as things go. The actual motion of the car was just up and back, but this is now at different times, this is where they are. This is a graph of distance or position happening over time. And we're going to use that to help us out today. I'm going to actually give you some scenarios, some words to look at to try and interpret and draw them on a graph that you have. You can either print out the one that I'm going to give to you, or you can go ahead and just use a piece of scratch paper and draw it right on the scratch paper to do it. If we were in the classroom together, I would pass out whiteboards to everybody, and we do this as a big whiteboarding experience, the whiteboard extravaganza, but no whiteboards. We have to do it this way as the best we can. So this is position over time. Now, when I say position over time, it is important to recognize this is a rate of change, how quickly kind of that position over time is changing. So here we go. Let's look at a potential graph to start this out. Now, this is a blank graph that I'm working with. If you were in a math class, this would look like an incomplete graph. In an algebra class, you typically draw graphs that have, 4 coordinates or 4, not coordinates, but regions in space, right? And those 4 different regions in space often have Roman numerals that denote them. So you end up with kind of 1, 2, 3, and 4 making its way around. And this here would be 1, and down here would be 4. So where's the other line? Well, it doesn't matter. If this is time going left and right, then there has to be some point in time. Time can't go backwards. So this is like our starting point in time moving forwards. Position, on the other hand, this is a positive position, or moving upwards on that train, and this is then moving downwards on that train here. The further up you go, the more positive you are, and the further down you go, the more negative you are. So let's look at a scenario and see if we can actually graph that and make sense of it. What I want you to do, right, is to draw some of these. So let's start by seeing if we can draw a picture like this on your piece of paper, and then we're going to try and put a graph over the top of it that looks something like this. A train is stationary at a stop for a bit of time, and then it moves off immediately at a constant, unchanging speed. So let's think about it again. Train is stationary. Stationary just means not stopped, or not moving, excuse me. It's a fancy word that just means not moving, right? So train is stationary, not moving at a stop for a bit of time. How much time? Not that important here. We're just trying to get the gauge here. And then it moves off immediately at a constant speed, unchanging. So how do you draw something like that? Well, if it is not moving for a bit of time, we would draw it something like this. Now, it could be down here, it could be up here, but nonetheless, it's not moving in its position. Its position is remaining the same over time. And then it said here that it moves off immediately at a constant, unchanging speed, which means that here it's going forward in this case, and it is moving forward at a constant, unchanging speed. So this is a potential graph of what that scenario could look like. Let's look at another scenario and see if you can put it up there as well. Here's scenario number 2. A train is stationary at a stop for a bit of time, sounds familiar, and then it moves off immediately at a constant velocity. We've done that, unchanging speed. And then it stops again, moves forward at a constant speed, and finally comes to one last stop, or stops one last time. Okay, so here's the tricky bit about videos like this. What I would like you to do is to try something out. I would like you to pause this video right now, read the scenario that you can see on the screen, and try and draw this on a graph where it's stationary for some time, moves out immediately at a constant velocity, which was what we did the last time. Then it stops again, then it moves at a constant speed, and then it finally stops one last time. So right now, I'm going to ask you to pause the video, try drawing this on a graph, and then come back and see me after you've drawn it. So pause now, and then come back. Okay, have you come back? I hope you tried drawing it. You didn't just keep watching. You will learn a heck of a lot more if you get involved. So this is what the graph might look like. In this particular graph that you're looking at, it stopped for a bit of time, just like it was the last time. It looks very much like the other graph. And then it is moving at a constant velocity, just like the last graph. But then it stops again. And then it moves at this constant speed, not speeding up or slowing. And then it stops here as well, right? So stopped, moving, stopped, moving, stopped. All right. You're getting the hang of it? Well, maybe. Let's see how this goes. On this graph, we're going to try drawing another one. So draw another one on your piece of paper. And it says the train is traveling at a constant speed. And then it gradually comes to a stop. It reverses direction and then gradually starts to move backwards at a constant speed. Train is traveling at a constant speed. Now we got that one already. Then it comes to a stop. You know what that might look like. The word that I need to emphasize here is the word gradually. So read this, see if you can draw it, and then I'll show it on the screen in a moment. So pause me now and then come back. All right. I hope you pause me. It's much more interesting to play along with the home game. All right, here it comes. Ready? This is what my graph looks like. It's moving forward at a constant velocity. And it gradually slows down and it comes to a stop. This is a stopping point right here. Train is no longer moving up or down, and then it speeds up in the opposite direction going backwards. If I was to draw this kind of what this train is doing on this piece of graph here, it doesn't matter where it is in time. Let's say I just drop it here. It's moving forward for a bit, and then it slows down and it stops, and then it speeds up slowly, and then it starts moving the other direction. Again, it could be over here. So it's going quickly, slows down, stops, comes back the other direction, and speeds up again, right? So that's what the train is doing, if that was my mouse. All right, here's the next one. Best of luck to you. We're going to redraw this graph on a new graph and see if you can take this and put it onto that graph. In this one, the train is stationary at a stop for a bit of time, and it gradually speeds up in the reverse direction. And then it gradually comes to another stop. And then it gradually speeds up in the forward direction, and finally slowing down to another stop. All right, pause it, draw it, and then come back. All right, so here's what my graph looks like. It looks just like this, right? So I was stopped for a time, and then started moving backwards and slowed down and stopped for a time, and then started moving forwards and then slowed down and stopped. So that's my scenario. Stopped, backwards, stopped, forwards, stopped. Cool. Now that we've tried all of these ones, let's make it a little bit more complicated. Velocity is a fancy word. But it shouldn't be. The words speed and velocity are very nearly the same thing, and I'm willing to bet you've probably heard this in a middle school before this time. I sure hope so, at least. Speed is just how fast you are moving, like how fast you're going, how quickly you are changing your position over time, right? Because you're changing your position. I can change my position very slowly, or I can change my position very quickly, and speed is just that. Velocity is a recognition that you change positions, but the positions are not all equal, and so you can change positions in a particular direction. I could step forward, I could step backwards, I could step left, I could step right. In middle schools, we often throw in like the velocity in terms of direction of northeast, south, and west. But when you get into a physics class in high school or college, we often think about velocity not in northeast, south, or west directions, but we think of them in positive or negatives, kind of like Cartesian coordinates. Right, so let's go ahead and continue to say that moving upwards is in the positive direction, and therefore our speed increases in the positive direction as well. And the negative would be slowing down or increasing in the opposite direction. All right, let's see what I mean by that. Here's a scenario. A train is moving forward at a constant, unchanging speed. This time around, we're going to put in not a position time graph, but this time it's going to be a velocity time graph. And so on the velocity time graph, this is going to be velocity on this axis, right? And zero velocity would be here. That means not moving. On the flip side, if you are traveling forward at a constant, unchanging speed, this line here is an indication of that moving forward at a constant, unchanging speed. You're still traveling forward at a constant, unchanging speed. What would this be then? The train is moving backwards at a constant, unchanging speed. How would this graph, where it's moving forward at constant, unchanging speed, be different if you were moving backwards? recognizing that velocity involves positives and negatives. So backwards would be a graph that looks like this, right? This is now moving backwards at a constant, unchanging speed. How about this? A train is moving forward at a constant, unchanging speed. You got that already, right? And now it immediately moves backwards at a constant speed. And then it finally immediately moves forward again at a constant speed. Based on these two graphs that you just saw, this one backwards and this one forwards, what would this scenario look like? Pause me, try and draw it. Velocity on the side, time on the bottom. Let's see what you got. Okay, coming back again, this is what mine looks like. Constantly moving forward, then constantly moving backwards, then constantly moving forward again. If I was to kind of use my mouse to understand what's happening here, I would be constantly moving forward, constantly moving backwards, constantly moving forward. The big deal here is that the transition points, if we think about it, are not nice. These edges right here are quick transitions. So forward, backwards, forward, right? There's no slowing down. It's just an immediate change. How about the train speeds up at a constant rate from rest? It speeds up. So it's no longer traveling at a constant rate. It's now speeding up at a constant rate, meaning that your speed is increasing constantly at a nice even rate. What would that look like? Go and pause me and see if you can draw this graph on a velocity time graph. Okay, let's see what you got. Here's mine. So it's stopped at this position, and then it is speeding up as we go. So the change is happening that it's becoming more and more positive, right? It's raising up. So its velocity is increasing. It's traveling faster and faster and faster and faster, right, as it moves along. If I was to kind of draw that with my mouse, it would be at a position where it's not moving to begin with, and it slowly moves at the beginning, and then it goes faster and faster and faster and faster as it goes. That's what this graph is showing. We have just a few more. We'll see what happens. The train speeds up at a constant rate, and then the train speeds up at a constant rate, then travels at a constant speed, and finally slows down at a constant rate. There's a lot of constants in there. Train speeds up at a constant rate, and then it travels at a constant speed, and then it finally slows down at a constant rate. What would this look like? Pause it, draw it, come back. Okay, here's what mine looks like. Speeds up at a constant rate, travels at a constant speed, slows down at a constant rate. So mine is here, speeds up at a constant rate, travels for a while at that constant rate, slows down at a constant rate. Did yours look like this? I hope so. All right, let's check the next one. Train begins by moving backwards. What would that look like? Velocity backwards? Quickly, and then it slows down to a stop, all at a constant rate, and then it speeds up in the forward direction at that same constant rate, meaning its speed is changing at a constant rate. Go and pause it if you haven't, and come back. Okay. The train begins moving backwards quickly, slows down at a stop, and concentrate. All right, this is my graph. It is moving backwards quickly to start with, and then it slows down at a constant rate, stops, this is the position that it stops, and then it starts moving forward at a constant rate, speeding up. If I was to kind of use my mouse to draw this, again, I would be moving backwards at a constant rate, slowing down and stopping, and then starting up the opposite direction and moving forward, right? This is backwards, this is forwards, this is stopped. We're going to leave this last section for another video, but I thought I would go ahead and give you a start of position over time and velocity over time. And I'm going to give you another chance to practice this at home using a simulation from the physics classroom, so we'll check that out in the homework, but hopefully you are able to follow along with this, and we'll see you next time.